Let's practice some LCM, or least common multiple application word problems together. In number 1, Benny the dog is going to be getting a big dog treat every 8 minutes, and he's going to be getting a small dog treat every 3 minutes, okay? The question is, when is the very first time, that Benny's gonna get both treats at the same time? All right, so this is a classic LCM type problem. Then the question goes on to ask, when are the next 3 times that Benny gets both treats? So we can go ahead and just use the ladder method if we would like to right now. And so the first one is going to be every 8 minutes, and the other one is going to be every 3 minutes. So if we go ahead and use maybe the ladder method here or the cake method, we see that 8 and 3 are actually relatively prime. So we're gonna just put the 1 on the side here. So we still have an 8 and then we still have a 3. Okay, at this point, I think we are all done. I think we can just multiply these outer numbers to get the LCM. If you go ahead and multiply 1 by 8 by 3, this L creates the LCM. So we find out the LCM 1 times 8 is going to be 8, and 8 times 3, that's going to be 24. And because their 8 and 3 were relatively prime, or their GCF was equal to 1, we knew that was going to happen. And you could have also just multiplied 8 times 3, or this 3 times 8, and you would have gotten that 24 as well. So at 24 minutes, so the first time, let's go ahead and write it like this. The first time is going to be 24 minutes, right? After that, we're gonna go ahead and say, when are the next 3 times? So then if you go ahead and do the second time that's gonna happen, that's going to be 24 times 2. So that's gonna be at 48 minutes. And then the third time is going to be 24 multiplied by 3. So if we go ahead and do 24 times 3, you should get 72 minutes. And then finally, for the next 3 times, right? So we have the first, second, third, and fourth time this is going to happen. Then we can go ahead and say, what's 24 times 4? And that should be at 96 minutes. So these are the next 3 times that Benny's gonna get both treats. Again, the big idea here is if you would like to list multiples, you could as well. So for 8, we have 8 and then 16 and then 24 and then 32. This is how often he's going to be getting the big treats. And if you want to see these listed out for the small treats, it's every 3 minutes. So 3, 6, 9, 12, 15, 18. We can go to 21, 24, 27. So on and so forth. So that very first time that you can see that they hit the same number is going to be at 24. So if it helps to see them listed out, then that is helpful maybe for you. But again, you don't need to list for every single time. You can use the ladder method, the cake method, or prime factorization if that is more helpful. Here's number 2. For number 2, Miss Jager eats a huge waffle, okay, every 15 days, and then gets then a triple scoop of ice cream every 9 days. So lucky Miss Jager having some waffles and ice cream. The question here is, when is the very first time that Miss Jager gets to eat both the waffle and ice cream on the same day? So again, another classic LCM example. And then when are the next 3 times that this occurs? Okay, so let's see, 15 is for the waffle, and then 9 is going to be for the ice cream. And so we can find out when they meet by listing them, or we can go ahead and use maybe the ladder method. For 15 and 9, I'm thinking a common factor here would be 3, right? 3 goes into both of these numbers. 3 goes into 15 5 times, and then 3 times 3 gets you 9. So if you go ahead and multiply these outer numbers, then 3 times 5 times 3 should get us our LCM. So the LCM here would be 45. Right? Again, if you just want to do 9 times 5, that'll be 45, or 15 times 3, that'll also be 45. Then you can see here that the LCM, or the very first time, would be at 45. So I'm going to go ahead and write the first time. So the very first time, Miss Jager, I'm just going to write first here, eats both things, is going to be the 45th day, right? And then for the second time this happens, that's got to be 40 days later. 45 days later, that's going to be on the 90th day. When's the third time going to happen? That's going to be 45 days later. That's going to be on 135th day. And then the next time after that is going to be 45 days after that. So 45 after 135, that's going to be the 180th day. All right, so the first time it happened was going to be on the 45th day. This is going to be the LCM. But then after that, you're going to see the next 3 times Miss Jager has both on the 90th, 135th, and the 180th day. Here's number 3. For number 3, it looks like Mr. Lee is going to be eating a burrito every 18 days. So the burrito is being eaten every 18 days. And then for the taco is going to be eaten every 24 days. The question is, when is the very first time that Mr. Lee eats both a burrito and a taco on the same day? So again, very similar to the last couple questions. This is an LCM question. Okay, so we can list out all the multiples, but it's a little quicker if we use one of these other methods. So for 18 and 24, we can go ahead and use the latter method maybe. What goes into 18 and 24? I'm thinking 6. 6 times 3 is 18, and then 6 times 4 is 24. If we go ahead and multiply everything along the outside here, we can see 6 times 3 is 18, 18 times 4. You can go ahead and multiply that or pause if you need to. That should equal 72 though. You could have also just done 24 times 3 or 18 times 4. Those would also get you 72. So when's the first time Mr. Lee eats both of these burritos and tacos? So the first time, that will just be the LCM. That's going to be the 72nd day. Okay, and then for after that, let's see. The second time should just be 72 times 2. So 72 times 2, what is that, 144? So it's going to be the 144th day. Okay, and then if you go ahead and multiply 72 times 3, then the third time this is going to happen is going to be the 216th day. And then if we go ahead and multiply 72 times 4, so the fourth time this is going to happen, this is going to be the 288th day. Okay, so these would be each of the times that's going to occur. The first time is going to be on day 72, and then every 72 days after that, Mr. Lee is going to eat both on the same day. Cool. Moving on to number 4, a blue light is going to blink. So a blue light is going to blink every 25 seconds, and then a purple light is going to be blinking every 15 seconds. The question is, determine the very first time that the blue and the purple light blink at the exact same time, and then determine the next 3 times this is going to occur. Okay, so we have 25, every 25 seconds, that's the blue light, and then every 15 seconds, that's going to be for the purple light. I know it's a little confusing, I'm not using those colors. I should have used blue and purple maybe. I could list out all the multiples, but I'm gonna use the latter method. 5 goes into both. 5 times 5 is 25, then 5 times 3 is 15. And if we go ahead and multiply these numbers along the outside, this should get us our LCM, or you can say 15 times 5 or 25 times 3. So you can see the LCM, or the first time these numbers meet, would be at 75. If you need to pause to do the multiplication, feel free to do so. Okay, but the very first time, I'll go ahead and write first, and it's going to be at 75 seconds. All right, SEC for seconds here. That's the very first time. Then after that, it's going to be every 75 seconds after that. So the next time is going to be 75 times 2, which is 150 seconds. And then for the third time, that's going to be 75 times 3. I think that's 225 seconds. And then for the time after that, it's going to be 75 seconds later. That's going to be at 300 seconds, also known as 5 minutes. So every 75 seconds, these 2 lights are going to blink at the exact same time, and they'll be lined up. All right, for number 5, you eat a Sour Patch Kid. Every 144 milliseconds, and then it looks like you're going to eat a Skittle every 234 milliseconds. Determine the first time you eat both candies at the exact same time. All right, so we go ahead and write these larger numbers down. We have 144 for the Sour Patch Kids, and we have 234 for the Skittles. And so these numbers are pretty big, so they're both even numbers. So maybe start with the number 2. And so 144 divided by 2 is 72. Feel free to pause and think about these or do the division on your own. But I'm just going to go ahead and keep going because I know you can pause if you need to. Half of 234 should be 117. Okay. Now I think we can keep going here. I'm noticing here that 72 is divisible by 3 because 7 plus 2 is 9, and that's a multiple of 3. And then 1 plus 1 plus 7 and the 117 equals 9, so that's a multiple of 3 also. So 72 divided by 3 is going to be 24. and then the 117 divided by 3, that's 39, I believe. Okay. Now, if you look at these two numbers, I actually think you can divide these by 3 again. 3 times 8 is 24, and then 3 times 13 is going to be 39. Now, 8 and 13 are now relatively prime. So if we want to multiply all these along the outside, this should get us our least common multiple, or our LCM. Or if you just feel like doing 234 times 8 or 144 times 13, that works as well. Okay. If you wanted to write out prime factorizations, you could also do that as well. So like 144, if you make a tree for it, I think what's going to end up happening is you should get 2, 2, 2, 2, 3, and 3, if I'm not mistaken. I think that makes sense. And then for 234, I think that's going to be 2, 3, 3, and 13. Okay, so if you wanted to use the prime factorizations instead, feel free to do so. Just might take a little bit of time to break these numbers down, but knowing your divisibility rules, especially for 2 and 3, can be super helpful here. Okay, now if we just go ahead and multiply, I don't know, it depends on what you feel like doing, but I'm going to do the 234 times 8. Can't do that in my head, so I'm going to go ahead and write that down. That's 32, carry the 3, that's 24, plus 3 is going to be 27. Carry the 2, 8 times 2 is 16, plus 2 is 18. So for the very first time this is going to happen, number 1 is going to be at 1,872 milliseconds. So I'm going to put ms here for milliseconds. The second time this is going to happen, we should take 1,872 and then multiply that by 2, or just add another 1,872. I think if you add another 1,872 or multiply by 2, that should be 3,744 if I'm not mistaken. And then for the third time, that should be another 1,872. So if we go ahead and let me see here, another 1,872, that should be in the 5,000s, I think 5616 milliseconds. Okay. And then the next time after that would be another 1,872 on top of that. So 56 plus 18 should be 7488, I believe. 7,488 milliseconds. Okay, so you'll probably have to write out multiplication. I'm assuming for most people would probably be the best way to do that, or if you're really good at adding in your head, or you should be writing it out. So I'm not actually writing out the multiplication. I think these are correct based on what I've done. So hopefully these are correct. So, but these should be the first 4 times that this does occur. All right, for number 6, let's see what's going on here. It says it takes you 126 seconds to run a lap around a small park, okay? While it takes your friend 216 seconds to do the same thing. Given that you both start running at the exact same time, determine the very first time that you are both at the exact same start location at the same time. All right, so you start and then you're trying to find out the first time you will be back at the start location again, and then you're going to find the next few times that occurs as well. So let's see, we have 126. So every 126 seconds you end up back at the start location, and then for your friend it's every 216 seconds, so you're a little faster than they are. And so let's see, these are both even numbers, so I'm going to start with a 2 because I know I can make these smaller. Half of 126 should be 63. Half of 216 I think is 108. All right, now for these two numbers I'm thinking of 9 using my divisibility rules. I know 9 times 7 is 63, but 1 plus 0 plus 8 is 9, which is a multiple of 9. So we can divide 108 by 9 to get 12. At this point, I think 7 and 12 are relatively prime. So if we go ahead and multiply these numbers out on the side, these should get us the LCM. Or we could just do 216 times 7 or 126 times 12. I think my preference is going to be multiplying 216 by 7. And so let's see, that's going to be 42, carry the 4. 7 times 1 is 7, plus 4 is 11, carry the 1. 7 times 2 is 14, plus 1 is 15. So for the LCM, I'm getting 1,512. All All right, so based on that, I think that the first time that you guys will be back at the same location is going to be at 1,512 seconds. Okay, and then for number 2, that's going to be the same thing, but another 1,512 seconds. So if you double that, I believe that should be 3,024 seconds. Okay, then time after that should be another 1,512. So if you add another 1,512, I believe that should be 4,536 seconds. And the next time after that, if we go ahead and add another 1,512, this should be 6,048. These ones are a little bit easier to add, 6,048 seconds. Okay, so again, if you needed to write the multiplication out, then please do so. And if you needed to write the addition out, please do so. All right, here's number 7. For number 7, Chipotle is doing a giveaway to celebrate National Chipotle Day. So we have every 48th customer is going to get a free taco. Cool. And then every 80th customer is going to be getting a free quesadilla. And then we see here that every 144th customer in line is going to get free Chipotle for a month. So free Chipotle for a month, that's pretty sweet. Determine the first customer, the very first customer in line that receives all 3 of these prizes. So that's going to be the LCM here. All right, so let's see here. We have 48, and then we have 80. That's going to be for the quesadilla. So the first one is the taco, the second one's the quesadilla. The third one is going to be getting the free Chipotle for a month. So that's going to be customer number 144. All right, so if we want to find out when these all meet, we can go ahead and find the LCM. So I'm noticing here that these are all even numbers. So if I put a 2 times 24 is 48. 2 times 40 will get you 80, and then 2 times 72 gets us 144. All right. Now these are all even numbers again. I think we can divide by 2, but I'm also noticing maybe we could just divide by 4 here, because I know 4 times 6 is 24, 4 times 10 is going to be 40, and I know 4 times 18 is equal to 72. All right, these are all even numbers still, so I think we can just keep going here and do another set of even numbers. So 2, that should be 3, and then 2 times 5 is 10, then 2 times 9 is going to be 18. All right, so I think 3, 5, and 9 are now relatively prime. So at this point, you just want to be careful and check to see if there's any GCFs between just 2 numbers. So this right here, this 2, 4, 2, this would get us our GCF, but that doesn't tell us our LCM. What we want to do is go a little bit further here. So it looks like this 3 and 9, all right, this 3 and 9, they both have something in common. So what we're going to do is we're going to keep going with this ladder method. This 5 is just going to swing on down. Didn't get used at all, so let's just bring this 5 straight down. And what goes into 3 and 9? Well, if we take a 3 out on the side, 3 goes into 3 1 time, then 3 goes into 9 3 times. All right, so you have to do this extra step to check for the LCM. And now that everything's relatively prime, like this 1 and 5 are relatively prime, this 3 and 5 are relatively prime, and then this 1 and 3 are relatively prime, then we're finally done. So the product of all of these numbers along the outside will get us our LCM. So if you multiply all of these together, okay? So when you have 3 numbers, you just have to be careful and actually multiply all of these along the outside. So the LCM here is going to be 2 times 4 times 2 times 3 times 1 times 5 times 3. So when you have 3 numbers, you're going to have to multiply all of these together along the outside. So let's do this together. 2 times 4, that's going to be 8, right? 8 times 2, that's going to be 16. Then 16 times 3, that should be 48. 48 times 1 is still 48. 48 times 5, that should equal 240. And 240 times 3 should be 720. So the LCM here I'm getting is going to be on customer number 720 is going to be getting all 3 of these giveaways. So the first person, number 1, is going to be the 720th person in line. Who's the second person in line that's going to get this? Well, 720 plus another 720 should be 1,440th person in line will also get this. The next person in line is going to be person number 2160. And then the fourth person in line, this is a big line, is going to be number 2880th person in line, right? So these are the first 4 people in line that'll get all of these prizes or these giveaways from Chipotle. All right, final problem here. Mr. Lee is training for an Ironman. That is a type of triathlon and does a tough swim workout. So swimming is going to be every 24 days. So I'll swim on other days, but the tough swims are every 24 days. And then I'm gonna do a tough run workout every 36 days, okay? And then finally, we're saying that we're gonna do a tough bike workout every 54 days. The question is, what is the very first day that Mr. Lee will have to complete all 3 tough workouts on the same day? So this is an LCM problem, right? So I'm gonna use this ladder method. We have 24, and then we'll take this 36, and then we'll take this 54. And be careful when you're dealing with 3 numbers. We have to be careful because we might have to find the GCF of just 2 numbers after we check for all 3. So for all 3 of these, I think I'm gonna start with maybe 6, because 6 times 4 is 24. 6 times 6 is 36, and 6 times 9 is 54. At this point, you should pause to think and ask yourself if there's something that goes into all 3 of these, but I don't think there is something. So you just have to pick 2 of them now and find the GCF. So I'm gonna ignore the 4 and just let that come down here, this 4. And I'm gonna focus on the 6 and the 9. So this 6 was our GCF, but if we look at 6 and 9, they have 3 in common, right? So 3 times 2 gets you 6, and then 3 times 3 gets you 9. I think we can keep going here because there's still 2 numbers that I think have a GCF. So we're gonna take this 3, and the 3 is just gonna swing on down here, and just take a look at this 2 and this 4. Looks like they both have a 2 in common. So 2 times 2 is gonna get you 4, and then 2 times 1 is going to get you 2. All right, so we found out that these were all relatively prime here, so only 6 went into all of them. And this 3 here didn't work for all of them, but it did work for just the 6 and the 9. And then after that, we realized that this 2 does work, but just for the 4 and the 2, but not the 3. So at this point, you can notice here that these are relatively prime, the 2 and the 1. The 1 and the 3 are also relatively prime, and then the 2 and the 3 are relatively prime. At this point, once you've exhausted all common numbers, then you can go ahead and multiply the L here to get the LCM. Okay, so again, the LCM when you have 3 numbers is definitely more challenging, so I totally get that. It's going to be 6 times 3 times 2 times 2 times 1 times 3. It's going to be the product of all of those numbers along the outside. So let's see here. We have 6 times 3, that's going to be 18. 18 times 2, that's going to be 36. 36 times 2 is going to be 72. 72 times 1 is still going to be 72. And then 72 multiplied by this 3 at the end is going to be 216. So 216 should be the first time that Mr. Lee has to do all 3 of these tough workouts. So when's the first time? Time number 1 is going to be the 216th day. And then time number 2, if you double that, I think that's what, 432nd day. Then if you go ahead and let's do the 3rd time this happens. So that's going to be what, 216 more than that. I think that's going to be 648th day. And then the 4th time this happens is going to be 216 days later. And I think that's going to be the 864th day. All right, so the very first day was this day number 216. And then after that, it's always just 216 days after that. All right, so there you have 8 different practice problems dealing with applications for dealing with the least common multiple. Sure, can you list out multiples? Absolutely. It just becomes a little bit less efficient over time. So hopefully the ladder method is useful to you. You can also use prime factorizations if you would like to, but hopefully you found this helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.